and hopefully have like a time reference of when each question is going to pop up. So I'm assuming average about 7-8 minutes a question. So that in mind, have I think altogether 12 questions submitted. So mostly GChem. Admit one more person. So a pKa question followed by a pH question, followed by a pKa question, followed by a pH question, followed by a pH question, a pH applied to amino acid question, a pH pKa question, and then finally a little bit NMR and a little bit of physics. And then back to the pH pKa. So just, I'm assuming that means homework-wise, you guys are starting to get into the acid base. So I will go ahead and get rolling on this. Anybody want to be the co-host to let somebody in just in case I can't? I will pass it along then. And thank you in advance for all the hard co-hosting work you do. Perfect. Okay, so we're on the right page with this one. Okay, so this is one of those things that, if you think back to biochem, did you ever have questions where they asked, what is a charge? Is this site charged or uncharged? The questions of that nature for a protein, amino acid, or any sort of structure in biochem for that matter, do they like figuring out whether things are charged or uncharged overall or site by site? Is that definitely right up their alley? And so that's what this question gets at. So, question, what happens when pH is greater than pK? And I always want to be able to solve this both mathematically and conceptually. So conceptually speaking, pH is higher, deprotonated, exactly. So the pH is higher, basic environment, proton goes away, exactly. And then Henderson-Hossbach, just to verify that, pH equals pKa plus log of AHA. If this number is larger, then this number must be positive, which can only be possible if the numerator is the big one. Okay, so according to the Henderson-Hossbach equation, deprotonated has to outnumber protonated. According to intuition, higher pH than pKa, deprotonated. Okay, so with that in mind, I want to go site by site by site. So is 7 higher than 6.05? So this is going to be D. Is 7 higher than 1.81? Yep, so that's going to be D. Is 7 higher than 9.15? Nope. So that one's going to remain protonated. So that one's going to just stay as is. So the 9.15 degree is legit here and legit here. Okay, so if this one gets deprotonated right here, so let me get rid of that and make it deprotonated. Now I'm going to worry about pKb, a CO2 minus, which degree is 12.19. And then this right here is going to get deprotonated. And now this is going to worry about a pKb of the R group equal to 7.95 because it's in deprotonated state. Yeah, exactly. Oh, no. I'm sorry. Yeah, exactly what Jonathan said. 14 minus. So pK plus pKb equals 14. So if you know what pK is, just subtract it from 14 and you get pKb. So I think, more than anything, would you agree this question is poorly worded? And being the one who wrote the question, I'm guilty of it. I don't know how to have asked for what I was looking for, but I decided years ago just to leave it as is. When people get it wrong, they start looking in the answer explanations and hopefully run across that whole 14 and some of the other things that are helpful. So this definitely qualifies in the learning question category. They can ask something like this by all means, but they would word it significantly better than I worded it. But does this question make sense? What we're getting at? Perfect. Okay. So I will migrate on to the next one then. So which of the following has conjugate pair mixtures has the lowest pH? So for a conjugate pair mixture, do you need a pH calculation that involves just the base, just the acid, or both? You need both. So pH equals pKa plus log of, aha. And again, are you okay with me not bracketing it? Because liters cancel liters, so it's moles over moles, molarity over molarity. Any mole-based unit, as long as it's the same mole-based unit for numerator and denominator, we're good to go. Okay, so if I want the lowest pH, tell me what I want. Do I want a high or low pKa? I want a low pKa, and do I want more acid or more base? I want more acid, because if the denominator is bigger, the number is less than 1, log number less than 1 is negative, so it's going to be even lower. So in this case then, can I get rid of, based on, let's do first lower pK, can I find out what the pKs are? And I look it up and I find out that HF is around 3.3, ammonium is around 9.3. So can I get rid of the ammonium answers right away? And realistically, you should know the amino terminals 9 to 10, so that's not a stretch to know that one. This new degree is kind of memorization. And unfortunately, this was a freestanding question, so you were kind of hung out to dry on that one. MCAT test writers are much better about giving you information, so they would give you far more information than that. This one you should know, though. Yeah, but the thing is, you remember it after repetition. Yep. And so be mad at yourself, but get over it, because the more you get exposed to it, the more you're going to remember this. Okay, now it comes down to, which is the acid, HF or KF? Perfect. So 15 of 0.1 is more than 10 of 0.1. So does that make sense then? And is it worth plugging the numbers in, or how many are okay at that point that you don't really need confirmation? Okay, perfect. I'm going to put the numbers real quickly to say 3.3 minus a little bit, 3.3 plus a little bit, 9.3 minus a little bit, because it has more of the acid, and 9.3 plus a little bit, because it has more of the base. Yep, and that's exactly it. So how many are starting to get that way? Give up the anal perfection and make a good choice and move on. How many treat it more like one of those game shows where you go through one event, get it done fast, go to the next one, get it done right, but move on to the next one? There's a clock in the back of your head that should keep you going. Make a good choice, move on to the next one. Make a good choice there, keep on moving. And realizing it's how you think, not what you know. What you know helps, but how you think is far more important. Okay, so hopefully this seems reasonable. This one, a couple people submitted this one. And so what I want to do is I want to take my time and spread this out thoroughly and say, if I have a diprotic acid, first proton can come off and give me HA minus, for instance, something with carbonic acid. And then HA is capable of going to H plus A2 minus. I'm not going to put any aqueous symbols just because I'm being lazy. So this first proton coming off this way would make this pK 1 or 2. pK 1, perfect, first one off. And then pK 2 for the second one. And is pK 1 higher or lower than pK 2? Lower. So the first proton is more acidic because once you take one off, it gets harder to take the second one off. So pK1 is always less than pK2. Okay, I'm going to call this pKb1 and pKb2, and you correct me. Actually, I'm going to write it slightly differently. Forgive me for this. There's a method to my madness. I'm going to call that 1 and 2. Have I gotten those correctly labeled? Yes or no? Nope, Todd's going to lie. They are not named for their corresponding pair. They're named for sequence. Which is the first proton to come back on? The lower one or the upper one? Lower one. So going backwards, the first one coming back on is pKb1. The second one coming back on is pKb2, which means that's a conjugate pair, and that's a conjugate pair. So we have pKa1 plus pKb2 equals 14, and we have pKa2 plus pKb1 equal to 14, because again, conjugate pairs add to 14. So I know a couple things here. I'm going to throw one more thing, and that is pKb1 is less than pKb2 because it is more basic. So got that one, got that. Perfect, I'm set. So time to start looking at answer choices. Is this a true or false statement then? Choice A. True. Choice B. Choice C. Oh, welcome, Brooke. Jonathan must have let you in. Sorry if I didn't even notice. My apologies. This one's a little bit tricky. So let's plug in one of two ways. So I'm going to do it this way. I'm going to say pKa1 plus pKb2 equals 14. So if I were to replace this with pKb1, am I replacing it with a larger number or smaller number? So which is more basic, the first proton or second proton? Coming back on, the first base picking it up or second base? First base is more basic. 2 minus can pick up a proton more easily than an HA minus. Do we minus 2 attracts an H plus more than a minus 1? Meaning this is in fact more basic, which is why pKb1 is lower than pKb2. So therefore, if pK1 plus pKb2 equals 14, and you replace pKb2 with a smaller number, then that also has to be smaller. So how many would give that a tricky but true? And then D is my only one I feel completely confident in, because that's one of those just definitions. So was this a pain in the butt one? Oh, it's so easy to get flipped on your head. Why do you think I wrote everything down? Truth be told, to do it in your head, next to impossible. I think you need to write it down. And that's where this test becomes time consuming. Do anything you can in your head while you can, but every now and then there are going to be just some things you just flat out have to just do. I mean, you're going to have to just write everything out. You can't shortcut it. Like drawing structures in OChem, occasionally you just have to do it. Figuring out this pH and pK relationship, or pKs relative to one another, just have to do it. So I'm okay with the information, but would agree this is kind of a butt-kicking question. Okay, free to move on, because this one was multiple people submitting it. Okay, onward we march. This, I think, is the hardest of all the questions. Not to, like, anybody who turned a different one and found this one easy, sorry, that's probably seriously one of the worst things you say as a teacher. Oh, those other ones are so easy, you didn't get them, you must be worthless, because this one's hard. How many, is that what you heard? Even though I said this one's hard, how many heard I got the other one wrong and thought that it was hard, so I'm worthless? Totally didn't mean it to go out that way. And I realized in the page 2 of the student manual of how to teach, that's probably right there. But let's go ahead and figure out what we have going on here. I have H3PO4 with 3 protons and Na3, so 3 pluses for that, meaning PO4 3 minus. So I'm going to label those on the curve. I'm going to say this is where I have H3PO4, and up here is where I have PO4 3 minus, which means altogether I have to pass through 1 equivalence point, 2 equivalence points, and 3 equivalence points to get there. So how many agree? First proton, take that completely. Second proton, take that completely, and then third proton. How many are okay with the curve so far? Okay. And then as long as I'm doing it, this is going to be a pKa because it's weak. This is going to be pK because it's weak. This is going to be pK. So help me out. This is pK 1, 2, or 3. 1, lowest 1, perfect. pK 2, perfect. And pK 3, I'll do that one all by myself. So we're good to go. Yes, exactly. Michaela, why do you say that? Why do you say this would also be pKb2 if we were going down base-wise? You're talking about this one or which one? No, so it goes, this is what's kind of weird. It isn't 1 goes with 2 and 2 goes with 1. It's 1 goes with the last and the last goes with 1, meaning pK1 would correspond to pKb3, pKa2 would go to pKb2, and pK3 would go to pKb1. So it's just running it backwards. So kind of like, in DNA, you have 3 to 5 in one strand and 5 to 3 in the other. Same thing here, 1, 2, 3. And then if it's 1, 2, 3 for one of them, it's got to be 1, 2, 3 going the other way. If it's 1, 2, 3, 4, 1, 2, 3, 4 the other way. Hopefully it seems okay. Anti-parallel, exactly, going in that opposite way. So, and when you put words like that, does it suddenly make more sense? Yeah, and it's something like that. Yeah, and it's, yeah, adding hydrogens back on would be going down the curve. Exactly. Oh, hot ovens, hydrogens, whatever, it's all the same. But there are certain things that really carry over. Like I noticed, I was curious how Prachi did, and so I was looking at one of the questions she went over, and it dawned on me, I've never taken genetics, so I apologize that I have no insight other than she wasn't doing genetics, she was doing probability. And so is it okay if I go off on something totally unrelated that I thought was kind of cool in that one, that's just basic statistics? Red, 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 and brown. I don't have a brown, so it's got to be that one. And your red population was 31, your brown was 9. And they said some generation crossing red with red. And what do you get? Okay, well, you guys actually said this was an RR, this was an RR, RR, and RR. Okay, of all the combinations, this one and this one, this one and this one, and this one and this one, we'll see what we get. So if you were to take an RR with a small r, big R, those two were to cross, you agree, because of the big R, it's guaranteed to be red. And if you did RR with RR here, guaranteed to be for red. The only combination, big small, is the only way you could get both, some with big R, some with small r, the only cross. So it's only this one crossing with this one that can give you the chance for multiple possibilities. Okay, out of 31, how many out of the 31 total reds, how many are RR compared to RR? That was so horrible, but because it's a probability thing at this point. So you have a pool of 31, 10 to 20 roughly, that's what we get. So basically it should be 1 to 2 to 1. It's 31, so it's a little bit weird. So I'm going to tell you the chance of drawing this one is getting that. Chance of getting an RR will be 20 0.67 out of 31. And that's, again, a 1 to 2 chance. So I'm just tossing that number in there. It's an ugly number, but I'll just stick with it. But basically, I think she went with 30 and instead of 30 and 10, 31 and 9. So it didn't look like you were a monk cheating on your P genetics. So out of that, that's your probability for the first one being RR. And then now that you've taken one out of the pool, the next one is 19.67. That's how many are left out of 30 that could be RF. How many have learned that you take the events one at a time? So you have 31 here. So you have 31. So man, I'm trying to hit this so perfect. So you have 31 total here, and it's 20 out of 30, but because she gave a weird number, I have to stick with that. So 20.67 out of 31 chance. And then how many understand what the second one is, what this means? So I'll give you like a real life example. What are the odds of drawing 2 diamonds in a row out of a deck of cards? Do you agree? The first one is 13 out of 52 times 12 out of 51. Why is it 12 out of 51 for the second one? One card is already gone. Now you only have 51 possibilities, of which 12 are left. But would you agree that's kind of 1/4 times 1/4 for all intent and purpose? So 1/16 and a little less than 1/16 to get 2 suits in a row. So that's the same story here. Initially, out of the 31, 2/3 of the 31 are this one. So your chance of drawing one of these two is 2/3, the first draw. And the second one, it's slightly less than 2/3, ever so slightly less, meaning this is going to equal 2/3 times a number slightly less than 2/3, which means it's going to be slightly less than 4/9. So does that make sense from a probability standpoint? Just independent events, drawing what you draw. And NMR has a probability component. Genetics has a probability component. So does that make sense? So does this make sense for card drawing? Does this make sense for the events? It was something where she had the first generation was RR, crossing big R, crossing small R to get the distribution of RR with one small, and then RR. And I mean, it's just basically, yeah, she came up with 2/3 times 2/3 for 4/9. Yes. Yep, because once you pull one person out to breed, they have to have somebody else to breed with. Once you pull one card out, so yeah, if you reshuffle, so let's say you reshuffle, pull one card, and shuffle everything in, then it would be 13 out of 52 again. But 2 dependent events. One happens and the other one follows it. And so that's that probability of the first draw, probability of the second draw. Or meaning, oh yeah, exactly. I guess if you have 2 decks, 2 separate decks, yeah, then yeah, if it was a diamond or a heart, then it'd be 26 out of 52 times 25 out of 51, something like that. The total possibilities, it could be one of the things you need. So let's say, for sake of argument, you wanted to get a diamond and a heart, then yeah, it'd be 13 or 26 out of 52 for the first event, but then it would be 13 out of 51 for the next event to get the other one. So if you drew a diamond, you could draw a diamond or a heart for the first one. So either 26 out of 52 of getting it, but then it's 13 out of 51 for the second one, because you have to get specifically the other suit, if that makes sense. Anyway, I've gotten off on a tangent for this, but it has to do with that whole, like, how you correlate things. Math is kind of cool in a creative way, but oh no, it's not making complicated at all. So what I'm saying is that, going all the way back to where the story comes from, I'm describing 1, 2, 3 going up, and then 3, 2, 1 the other way, or 1, 2, 3 in the opposite direction. And when you guys said anti-parallel, it's because you speak fluent biology, which I don't. But does that help anybody? The thought of anti-parallel? PKs go up, PKBs go the opposite way when they pair up. So how many are like, oh, that makes total sense because you speak fluent biology? Well, I speak fluent chemistry and probability. So when I saw the genetics question, I had no idea about the crosses and Punnett squared, but I do know the event probability. And so if you can take what you know and apply it, that's what matters. So it's like a random draw, 20 of the 30 for the first one, and then 19 out of 29 for the second one, if it was a 30-10 distribution. So, and this is what I'm curious about. For those of you who actually do well at genetics, was that a pretty typical question, that probability one she had? For anybody who remembers it? Okay. So they really do like their probability. Oh. Yeah, and I think part of it is because coming from things from a totally different angle helps. Yeah. And honestly, when you guys said anti-parallel, I'd never thought of that before, but I'm thinking that's genius. That's exactly what it is. Anti-parallel PK and PKB. And so these are the kind of things that if you can do that, apply it, look at it a different way and apply it to something you know, how many will never forget that for the rest of your life now? Because it now clicks with something you already know, you've piggybacked onto previous knowledge. The more you do that, the better. Okay, back to being a G chemist. Okay, so let's consider where we're going to finish in each of these cases. But you know what's really, really cool is that biochem, to me, taught titration curves better. I didn't know them at all in GChem. GChem didn't teach me squat. One really good class in biochem, all of a sudden, like, the light went on and it was just beautiful. And I think that's kind of what this is, I hope. Okay, how many millimoles of each do I have? So tell me, what am I mixing in choice A? Am I starting way at the bottom or starting way at the top for choice A? Starting at the top because this is the Na pluses. So this would be this one. And am I adding, how much equivalent am I actually adding? So in this case, so I'm starting here in choice A. Am I adding more than equivalent, one equivalent, less than equivalent? Less than one. So I'm going to go down, but I'm going to stop around here. So would you agree A starts with the base and I add less than equivalent, so I'm going to get here for the equivalence point. Okay, I'm going to leave it at that because I don't know the exact number. I don't want the exact number for now. I'm just going to hang on to it. What am I starting with in B? Okay, so how do we know to start at the top? Jonathan, explain to me, how did I know this was the top? Because you're our latest member of the top club. So how do you know this is PO43 minus? What clue did you get in that compound with PO43 minus? Na plus. Perfect. So yeah, there's no hydrogens, exactly. Instead of H's on there, you have NAs. NAs are like salt. Well, they are salt. This is the cation of it. They go away. So I have 1, 2, 3 of these, 3 pluses, which means phosphate must take on the 3 minus. Don't you dare say sorry for that. Sorry to yell at you, but don't you dare say sorry for that, because your question, I guarantee you, it matches other people's questions. And so rather than saying sorry, what you're going to say is the following. I owe you bio genius or physics genius or cars genius or sociology genius or whatever. You give and you take. If you ask a question here and get help from somebody, perfect. But now you owe genius in some other area as part of the team. So you're going to help us and save our butts on a handful of topics in exchange for somebody helping you. That's the way this is going to work. Dang it. Dang it. So hopefully that's a good way to go. Yeah, and you answered his question earlier, so it all balances. So this is the big picture of things. That said, sorry to yell at you, by the way. Where am I starting for this one? At the bottom, perfect, because it's all 3 protons on there. Am I adding half an equivalent, more than half, less than half, one equivalent? Less than equivalent. So I'm going to go up from here and finish maybe some around there before the equivalence point. Okay. In C, what am I starting with? Top again. And how much am I adding? Adding more than one equivalent. So let's see, 10 to 15, about 1.5. Yes, exactly. And volume and molarity. So you're absolutely right, but that's only because everything's 0.1. I really should be anal enough to multiply them together to figure it out because it should be moles. Because it's the same molarity, then it's just purely volume. So degree 15 is 1.5 times. Perfect. So it's going to go 1 and more. So C is going to end up around there. And then D. What am I starting with D? Top or bottom? D is bottom again. And how much am I adding? 1.5. One full one and another. So I've totally forgotten what the question's asking, but you're going to help me out. So B finishes here, C and D finish here, A finishes here. What is the question asking? Highest pH, which is which one? A is an awesome. Okay, so I'm going to mess with you because I'm mean and evil. What if it would have said lowest pH? What would the answer have been? B is in beautiful, perfect. So does this make some semblance of sense? Who's your friend? Who's your friend? No, the titration curve is your friend. What do you do with your friends? Again, I'm being biased to Southern Californians, but use them. Use your friend. So we're going to use our friend to get right answers. So does this make sense then? When stepping back on this, like, dang, that's a good organized way to do it without breaking out Henderson-Hasselbalch. And my goal in life, as little math as possible on the MCAT, I mean, I'm going to have to do math. I'm not an anti-math person, but it just takes time. And I'd rather get through it a little bit quicker. Okay, so are you believing you can use your friend for these sorts of questions? And my guess, typical test, maybe you'll get 4 or 5, maybe you'll get 1. It's kind of an all or nothing sort of thing. They either have a passage on acid base or they ask for it in biochem. Occasionally it's a freestanding question, but as long as you can do, like, work your titration curve, figure out where you're at on the curve, you're in good shape. Okay, anybody need to screenshot this? Moving onward then. In which of the following scenarios would a change in the net charge amino acid likely occur? This is an absolute screwy question, and I apologize in advance because I have not written it well. So just, I'm sorry. So this is one of those, you have to overcome my bad wording to get this right. So what it's getting at is, what charge is it initially and what does it turn into in the end? So if I have glutamic acid, let's start with choice A. How many degree glutamic acid, the N-terminal protonated? The C-terminal deprotonated? What about the side chain? Deprotonated. So overall, this is initially minus 1. If I were to add sodium hydroxide, what could it possibly go to? Maybe -2. Maybe I could take that proton off. Okay, I don't know if that answers my question right now, so I got to look at B. I got to go one by one and come up with some sort of answer and figure out what it's asking. So lysine initially would be protonated N-terminal, deprotonated carboxyl, and then plus, minus, minus. So overall +1, and if I add HCl, could it make it +2? Perfect. So what I'm getting at, what I think this question might be getting at is going from -1 to -2, it's still a negative charge overall. Positive, it's still a positive charge. So the magnitude is changing, but would you agree the sign is staying the same? So I think I might know what the question's getting at, although honestly, it's, again, not terribly well worded. I'm so sorry for the mess, but in this case, 0 going to, if I add base, -1, could be onto something here. And then finally, alanine. I don't know how I'm going to write this. I'm going to have to write it way over here because my palette's in the way. So I sincerely apologize for the lack of proper use of space. Okay, so here's where I'm running into trouble. C and D, do you agree, are both showing a gain of a charge, but one's going from 0 to +1, the other one's going from 0 to -1. And so there's got to be more to this question. So help me out. Am I missing something to do with isoelectric point? So I got to be a little more anal. So I'm going to tell you, I feel pretty confident in saying it is not A or B. But what is the PI for something like leucine, isoleucine, alanine, valine? Are those part of the Lysar his collection? No. So they get an average of pK1, pK2 over 2, which is about 2.5 plus 9.5 over 2, which equals 6. So now I'm on to something. When pH equals 7 and PI equals 6, agree it's slightly negative or slightly positive? When pH is slightly higher than PI, slightly negative, which means I need to correct this and say negative delta, and this one is negative delta. So which one is actually having a change in the sign of the net charge? How many would agree there's no way in hell you could have gotten it from the way I worded that question? This is one of those, you're going to miss it because I wrote a terrible question. This is another one of those that's left in there to work your way through in the hope. What I'm hoping for is that somebody reaches this PI decision. And I should change it in the future to be a change in the sign of the a change in the sign of the net charge. So if that would help a little bit. Yeah. It was really hectic. And somebody said they got struggle on determining the charges. That's really what this question was about, though, is just working through what the charges are. And so this is one of those that you can't win on this one. This is one of those that's set up to wreak havoc on your life and make you learn by skinning your knees, so to speak. And so that's, and again, does every chapter have a few of these? Those ones that punish you just a little bit? They would word it better than this. Yes, they definitely want you to know about what happens relative to the PI, in particular, what happens like electrophoresis, if it migrates, if we load it in one spot, which way would it migrate, load another spot, how would it migrate? Those are the type of questions. Or under what conditions would it bind from a column and release? So would you agree, let's say I had a column with a positive charge on it, this would bind weakly, but if I added base, it would bind more tightly. This would bind weakly, but if I added acid, it would release. So that kind of question, is that kind of what they're asking? Binds a cation or a plus charge column. So an anion exchange column would bind, but then release, bind, but not release. So that would be a fair question. That would be more realistic of what they would ask. Same concept you have to go through, but worded doable, if you will. So again, my apologies. If this one beat you up, it was kind of by design, but I think it still hit on the 6th thing. Exactly. That's what this is getting at. More than anything, PI is 6 and 6 here. It's higher than 7 here. It's lower than 6. So we have that. So hopefully this seems okay, or not that the question seems okay. So why is it not C? Because in C, we start off again with the PI being 6, pH being 7. So it starts out ever so slightly negative. So I go from slightly negative, and when I add base, it becomes fully negative. So I'm going from negative to negative, negative, negative in A, positive, positive in B, negative, negative in C. But in D, you're going from negative to positive. And that's why, honestly, the better question would be, which one would bind a certain column and then elute with the addition? So if this was a quality question, it would have been, which one could bind a certain column? So if this one bind and add the base, it would stay bound. If this bound a certain column, add acid, it'd stay bound. This binds a column, add base, it would stay bound. Binds a column, add acid, it would change sign, it would no longer be bound. That would be a more realistic way for them to ask this question. So hopefully it seems okay. And I will flick on. More biochem. Oh, you're very welcome. But also thanks for asking that question, because it is a butt kicker. And it's one of those where I think most people just read about it and blow it off and move on. And there's a lot on that question. That question is just a real time sink. But how many are actually starting to really get stuff out of by the time you're doing phase 2 or phase 3? Your scores may only go up a little bit, and that's because the questions get harder in a different way. Like phase 1, they're tricky in this sense, terminology. Phase 2, they're tricky in terms of timing. There's a lot of things that are look very much the same. In phase 3, everything gets integrated. So the problem is, you think with each phase you should be getting a higher and higher score. It should only be ever so slightly higher, because there's new sort of things that you're being messed with. It's not until you start doing practice tests that you start seeing the true step up. Okay, so for this one, which of the following tripeptide would result in a triprotic curve when protonated from low pH? Yeah, phase 3s, do your 1 and 2, but for phase 3s, hold off a little bit till you finish the whole book. So once you finish the fluids chapter, then phase 1 is fine, or phase 3, excuse me, in book 1 now becomes fine. And then in GChem just all over the map. I apologize all the time, and I realize I'm apologizing mostly because I bailed out in August. I just couldn't deal with the way things were running anymore. Just the fighting over things that should have been obvious and they weren't. And so I'm feeling kind of crappy that I did eject. And this is kind of what happened. I mean, just I'm trying to not address the elephant in the room, but I did notice when I logged in that there were 33 people attending at some point, at the highest number at all, and it was down to 22 by the time I checked in a little while later. So I assume it was another shit show. And I mean, should I add spec to the list of things to do? Yeah, it needs to be. And I'm yeah, NMR specifically. Because UV, it's either got a pi bond or it doesn't. And it's usually that's that extra little piece of information they throw. And luckily somebody posed that question. Oh yeah, needed lots of examples. So yeah, it is what it is. So one will pop up. Oh gosh, I know that was killing me. It was killing me to see that, but okay. Anyway, I think Tiffany's taken up to figure out what she's going to like keep an ongoing list of what people need and how things have been added to it. And so it sounds like thermo slash kinetics is one of the things you went in there. Yeah. Oh, Tiffany's freaking awesome. She's not here at the moment, but she's also just, I mean, people have stepped up. And the good news, I mean, making the best of an adverse situation is always a good thing. So, okay, so on to tripeptides. The catch on tripeptides is I only worry about the first amino acid's amino terminal. So if it's okay with you, I'm going to be totally anal and draw this thing out. Maybe even draw it correctly. So how many agree that when titrating from a low pH, what they're telling me then is that the C terminal is fully protonated? Okay. There is R1, R2, and R3. For this to be triprotic, I have 1, 2, I need one other proton to be active. So help me out. Tell me, what are my basics? Lies are his. That is so perfect. So lies are his. What are the two that end in the word acidic? Gluas, perfect. DE. And maybe I'm going to put them in purple because it depends. If there's cross-linking, no. If there's no cross-linking, cysteine possibly. The pH is high enough, tyrosine maybe. But normally we don't think of this because biological systems don't get up to over 10 and cysteine is cross-linking. So I don't do these two as a biochemist, but hopefully. Oh, it's okay. Oh, luckily. Oh, yeah. Okay. Actually, for anybody who's wondering why I'm stumbling and saying these words, somebody private might say something and then apologize that they've made a typo. And I was about to say, no worries, everybody does. But then I realized nobody saw the typo. So why the heck are you apologizing? It never happened. If it's in private, it never happened. So anyway, okay, so lies are his, gluas. So luckily, you know the one-letter codes. So one-letter code, what is the one-letter code for lysine? Perfect. K, R, H. And you already gave it to me, E and D. Oh, sorry, let me stay color consistent. My apologies. Okay, so let's go ahead and check this out. Would you agree? F no, A no, T no. Oh. S serine, isoleucine proline, nope. HAD, that could possibly be one. That could also be one. Oops. And then P, I, and E. So which one is going to add in one extra on the side chain? Perfect. So best answer then? And realistically, how many see this as a viable type of question they could ask? Yeah, D is the answer, not the letter, but exactly. So this would be triprotic. This would be tetra, di and di. So this is right up their alley. Is it fair to expect people to know the one-letter codes and which ones are acidic, which ones are basic? By all means. Yep, I don't think that 10,000% is high enough. I think even higher. Definitely have to know this. And sister is a gray area, and I'm going to just leave it here and ignore it. And I'm going to ignore it almost all the time. But when I am doing GChem, these two suddenly can join in the fun because it's not a protein and it's not a biological system. But in bio, cysteine crosslinks, tyrosine never gets touched. It's just these are the 5 I care about when I'm doing things like electrophoresis on proteins. It's when I'm doing weird stuff in GChem where I'm titrating that suddenly maybe I need to think about these two. Okay, free to move on. On we go. So 25. This one is an absolute pain in the butt, but got to go through it systematically and go through each of the PKs of interest. So they tell me venous blood is around 7.2. Is that true? So please tell me the difference between arterial blood and venous blood. Teach me a little physio before I go any further. So arterial blood, where does it start? Where does it go to? So artery out or artery in? I can't remember. Arteries away. I just remember throw your art out. You're a scientist. You don't need art. Throw your art out. So arteries go out. So arteries carry oxygenated blood from the heart out to the tissue. But what do veins do then? Venous blood brings the blood back. Rich or poor in O? Deoxy, like you said. But if it's deoxy, does that mean it's carbonated? And I choose my words different than bio. And I want to be careful because nobody will say it the way I'm saying it, but it helps me. Venous blood is carbonated blood. I'm just going to say it, just like soda. And venous blood is nothing more than like vampire soda. It's carbonated. Okay. In fact, how many learned that watching the what was that vampire series, Cullen series or whatever it was? And one of those, remember they talked about how vampires prefer venous blood to arterial blood because it's so fizzy? What we do in the shadows. Oh, actually, they probably would have something funny like that in there. But okay. So carbonated blood. So with that in mind, the pH is 7.2. So what's venous pH roughly? I'm so glad. I'm totally auditory the same way too. And let me see the big picture on that. How many say things to yourself as you're taking the test? How many say your mnemonics, chant your mnemonics? And how many hear a voice in your head? I mean, oh, I know, soundproof rooms would be awesome. Weird, but yeah, I can still hear a professor from when I was an undergrad who would always say, olefins do everything. He's a German professor, and I can totally hear that. Simply means you start with an alkene and you can turn it into anything in a synthesis. Olefins do anything. It was just awesome. Yeah, proctors, did they even care? Yep. Every now and then you'll get the crazy anal proctor who thinks that this is their stepping stone to take over some like Gestapo-esque sort of paramilitary group, but most of them just don't care. It's just most of them they're making their minimum wage, showing up way too early in the morning to make you sit down about a test that they don't know anything about, don't care. Just the way it is. Okay, all this for me to hopefully get back on track here. H2CO3 going to H plus HCO3 minus. pK1 is 6.4. 10.8. So I'm tossing an extra one in, but it doesn't matter if you know it exactly. You just know that it's much higher than 7.2. Nomenclature-wise, what is this one called and what is this one called? So what is the upper one called? So what is this compound called? Bicarbonate. Why is it called bicarbonate? Why? Because it is bi. It can go both ways. It can act as a base, pick up an H+. It can go forward, act like an acid by giving off an H+. It is bicarbonate. So hopefully it sounds familiar. Easy way to remember that. And is bicarb something that has biorelevance? By all means. So there's certain GChem molecules that are really biomolecules that we've just stolen for GChem use. This is one of them. Okay, so at 7.2, which way is this equilibrium going to lie? Is it going to lie on the acid or base side at 7.2? Going to lie on this side. And at 7.2, which way is this one going to lie? Acid side, perfect. And then let me toss the relevant one here. So 7.1 is pK2. So I'm going to put this one, which really doesn't matter. I'm doing it to be complete. This is the one I really care about because this is the one they gave me at 7.2. So this one, 7.2 on this side. Got my plus. And then 7.2 is 7.1. Oh, timeout. I'm so sorry. Anybody see what I screwed up on this one? Probably so. My inability, my reading skills have proven to, once again, my LA Unified School District upbringing is starting to catch up to me. 7.2 is above. That part's right, but this one over here, 7.2, slightly above. And then I apologize for scrunching this one in, but because I am coming up on my palette. Okay. Yeah, both of those 7.2, what's true? When pH equals pK, half and half. So good question. So 50-50. This one is probably going to be around 55-45. Yeah, so you said, what if they were both 7.2? So if the pK was 7.2 and the pH was 7.2, what happens when pH equals pK for a weak acid or a weak base? Half equivalence point. So it's at halfway point, the X point. So in a graph like this, that's where pH equals pK. That would be half base, half acid. When you have that situation. Oh, I have it memorized, but here's all you really could say. The difference every time you add a proton is about 5-ish, 4 to 5. So if this is 6.4, this is maybe around 11.4. If this is 7.1, this is going to be around 2.1 and around 12.1. Pure memorization, unadulterated memorization. And I apologize for that because, yeah, I'm throwing numbers out there. And these are freestanding questions. And the reality is they would give you a lot more information than I'm giving. Now, the one thing you can safely say, when the pH is within 1 of the pKa, so 7.2 is within 1 and within 1, that means you have predominantly this one going on. These two are in high concentration. This one is barely going to be noticeable. These two will be in high, that one and this one very low. Okay, So let's at least see which of these are true then. So is bicarb in a higher concentration than carbonic acid? Is that what we concluded here? That it's going to shift in that direction because pH is higher? Okay, I'm going to go with capital T because it's straight off what we read. Is bicarb higher than carbonate? So in other words, is this one, again, going to favor bicarb side? True. Is the -1 going to be more favorable than -2? That looks false to me, really close to equal, but do you agree, really, really close, but because 7.2 is slightly higher, it's going to be slightly more of this. So the 2 minus is going to be slightly higher concentration. And then finally, do you agree the 2 minus is definitely going to drown out that one? So I have a definitely true, a false but close to equal, and a definitely true. What is the best answer? C is in crap. It's not a perfect answer, but it's the one I got to pick. And again, how many have just grown sort of used to that? That about 1 every 2, 3 questions, the answer is not going to be perfect. It's going to be close, but not exact. So looking for good application of general information, not precise. So hopefully it's okay. So shifting gears then. So here's the NMR. Okay, before going anywhere, let's consider what the heck causes a singlet, a doublet, a triplet, whatever splitting we see. Splitting is pretty key. So the shift value, this 1.96, one we see right here, is typically attributed to something that's feeling a slightly stronger magnetic field than the one around 1.4. Just what it is. Not all, I mean, not all H's start equal, but not all H's live in the same environment. So for this particular compound, I'm going to have apparently a 3-to-1 ratio, like they say there. And then I need to figure out what is causing that shift value. So 1H at 1.96 attributed to hydrogen bond or hydrogen bonded to a carbon. So is this asking for what shape, how big it is, or the numerical value to describe what it's near? And so here's going to give you 2 questions, one having to do with chemistry, the other one having to do with life. So I'm going to pick up on something kind of was talked about the other day. Here's a metal pipe. Here's a haystack. Oop, sorry, hay is not red. And here's needle 1 and needle 2. Which needle, 1 or 2, do I need a stronger magnet to find? So I'm looking for a needle haystack. I'm really I'm going to go for 2 needles in a haystack. I'm going to do it by putting a magnet next to the haystack and try to find my needle. Is there any difference, even though 1 and 2 are identical needles, would it take a bigger magnetic field to find 1 or 2? Weird question, but it has something to do with this. Why would it take a stronger magnet to find 1, the needle next to the pipe, instead of 2? Because the slight magnetism that can be induced in the pipe is going to attract it. Okay, fair enough. Which needle is going to be harder to find? 1 or 2? The H's that are close to the oxygen, the H is a little bit further away in 3-dimensional space. Close. Why? for the exact same reasons that it was hard to find the needle near the pipe, the needle near the electron-rich environment. So if I have electrons are in motion, they create a magnetic field. The closer you are, you get attracted to it. There's a lot going on close to them. That sums it up perfectly. So the 1.96, is it the one closer or further away from the carbonyl? So the 1.96 around here and the 1.56. And there's trying to think like what other key things they gave on this one. Yeah. So this is the key stuff from the passage. So what does 1738 tell me? Carbonyl compound, perfect. And then what is a quaternary carbon? Carbon with 4 other ones attached. So a quaternary carbon, carbonyl, and then one other one there. Okay. So adding to this, why are they all singlets? No neighboring hydrogen, exactly. So how many agree electrons, they move around a lot, they create a really big magnetic field. Do nuclei spin? Kind of a weird question, but when we call it nuclear magnetic resonance, resonance is some repeated process. The repeated process is that the nucleus, the particles in the nucleus, the hydrogens and protons, they are actually spinning. They're not perfectly stationary, they're spinning. When they spin, do they create a magnetic field? Is that true? A charged particle in motion creates a magnetic field. But do they create a very strong one or a very weak one? Very weak. Doesn't really affect much, but it still can affect a little bit. But if it's far away over here, so weak it's not going to affect it. It only affects it when it's its neighbor. So you really only hear your neighbor's stereo. You really only smell your neighbor's bad exhaust or whatever. 2 or 3 doors down, you don't detect it as much. Same thing with this. So these H's on this carbon go 1 carbon away, no H's attached, 0 plus 1 singlet. These H's are all equivalent because CH3s are all in the same group. So again, 1 carbon away, no H's, they're going to be a singlet. How many are okay with this one then? How many are okay in saying then that this 1.96 is one closer to the needle? So, but what's the best answer in that case? Perfect, exactly. Everybody's gotten it right. So, and I noticed a couple of you did a small letter. One of you put a question mark on there. So is there, I mean, is there perfect confidence or is it, yeah, I kind of get this. I made a good choice and I'm going to move on. All of you got the right answer. Level of confidence, as long as you're getting the right answer. The singlet, yeah. No, let's go over, in fact, let's make it a point to go over what a singlet, doublet, triplet are for a whole bunch of compounds. But for this one, it comes down to, do you feel other magnets? So just like here, we said this one's close to the pipe, this one's further away. So this feels a stronger magnetic field. But what if there were a bunch of tiny little magnets nearby? Would that also affect it? Minimally, but it would affect it. H's are tiny little magnets. Their nuclei can spin. So the pipe is a big magnet. The tiny little H's are small magnets. The big magnet's going to affect it when you're nearby, but further away, it goes down. And the small magnet's going to affect it, but far less. But here's the tricky thing about the spinning ones. Do they spin clockwise or counterclockwise? can go both, either way. Meaning sometimes the magnet is pulling it in, sometimes the magnet is pushing it out. So can I go to a different blank page for this? Oh no, I forgot this one is, I worked out this one for a solution, so I apologize in advance. You're seeing everything. No, I did this one too, that's right. Okay, finally. Okay, so let me, okay, so yeah, let me go back to that graph then. So we see something like this. 0, 1, 2 ppm. What 1H means and what 3H means is if you did the area under this curve, the area under this curve would equal 1, or would equal 3, which means this is based on 1H, this is based on 3, or this is based on 2 and this is based on 6, or in the case we actually saw, this is based on 3 and this is based on 9. It means this peak is caused by the total number of hydrogens that are in a 1 to 3 ratio. Not a ratio of its carbons, a ratio of its hydrogens. Yeah, perfect. Oh, no worries. And sorry to jump on that one, because there is such thing as carbon-13 NMR. Carbon-13 NMR is not tested on the MCAT, but notice how it was in that last question we just did. They will talk about the information you get from it, but they'll never test you on it. So carbon-13 can show up in a passage and you will not be asked anything on it. So don't freak out. I mean, when you see it in there, don't worry. It's just simply telling you something about primary, secondary, tertiary, and quaternary. Those are some of the things you can find out from it. Okay, let me consider something different then. So I'll draw a line to imply the different example. So let's say we have this compound. Yeah, it was actually 3 to 9, exactly. 3 to 9 because it was a 3 connected to a carbonyl, connected to 9 equivalent, meaning all 3 of these are interchangeable as the same. So really it was a 3 to 9 ratio. Perfect. Okay. And the thing about NMR is it tells you 3 things: how many you have, how close they are to a significant magnetic group, and then how much it's next to other H's. There's almost too much going on. Information overload, it can stress you out. But let's consider then A and B. Let's start with, why am I calling this one A? You need to pick a letter, first in the alphabet. Are all 3 of these H's equivalent? Meaning, can they rotate and assume the same spot as the other ones? So all 3 in the same carbon, they are equal. Okay. Why is this one B? Why is it not why is it not also A? 2 different types of groups. Perfect. By symmetry, it is not the same. No mirror plane, no anything. Okay, so let's consider all the features of A and B. A is close to or far from the chlorines, relatively speaking. Yes, 9 together, all because they were all equivalent. So 1 to 3 really, because I now have more information, was actually 3 to 9, but it always gives me the lowest common ratio. And A, exactly, A is far from Cl, B is close to Cl. Is that going to affect the shape, as in doublet, singlet, triplet? Is it going to affect how many? Because it's close to Cl, is it going to make this 7 H's instead of 1? Or is it going to affect how strong the magnetic field is that we need to find it? This is the strength, exactly. So this will be at a higher ppm because of that. So ppm has to do with the other atoms, the Cl's, the O's, the N's. So the shift value you have to memorize comes from how close is it to a electron-rich, i.e. magnetic field-rich substituent or atom. Okay, the second question. This is 3 H's. This is 1 H. So you're going to get areas that will be 3 to 1. And I should do that backwards. Shouldn't have done that backwards. Okay. But the very last thing to consider, how many neighbors does A have? And what the heck does that even mean? Yes, it's backwards because the scale's backwards. Exactly. It goes 10, 9, 8, so down to 0 on this side. So A, if I go to this carbon, move 1 carbon over, how many H's? Just 1. So H is bonded to a carbon, go 1 carbon over, and it has a Cl, Cl, and an H. So 1 neighbor. For this one, H is on a carbon. We go 1 carbon over. How many H's on this neighboring carbon? 3 neighbors. So here's where it comes down to probability again. Like we mentioned, can this spin either clockwise or counterclockwise? And what we say, if it spins clockwise, we say it spin up. If it spins counterclockwise, spin down. So can this H have a nucleus that's either plus 1/2 or minus 1/2, spin up or spin down? How many agree either way? So if you have 1 neighbor, like you do, you're either going to get a little bit of addition or a little bit of subtraction. You end up getting a doublet in a 1-to-1 ratio. So let me redraw that because that looks like a letter. I'm so ashamed because once upon a time as an undergrad, I actually drew my own NMR. I turned in totally fictitious data for a lab and I drew it so well. It was the most artistic thing I ever did in my life, was cheating on a lab report. And now I can't even do it here. Kind of a shame. But a doublet meaning it has 2 peaks. Okay. For this one with 3 neighbors, this is going to be a little bit tricky, but help me with probability. When I have 3 neighbors, is it possible that they're all up, 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 spin up, spin up, spin up? Is it possible up, up, down, down, up, down, up, up, down, down, up, down, up, down, down, and down, down, down? Dang. Is that way too many things to consider? 1, 2, 3, 4, 5, 6, 7, 8, which makes sense. 3 neighbors, 1 out of 2 possibilities. 1/2 times 1/2 times 1/2 is 1 out of 8, meaning there are 8 different ways this can show up. This is going to be a big plus with 3. These 3 are going to be a small plus. 3 is small minus. This one a big minus, meaning this is going to add a lot, add a tiny bit, subtract a tiny bit, subtract a lot, which means 1, 2, 3, 4. Are there 4 different ways your neighbors could exist? 3 plus 1. Which means you will see 1 time adds a lot, 1 time or 3 times adds a little, 3 times takes away a little, 3 times takes away a lot, and you end up with what's known as a quartet. So you start getting used to this. This is the n+1 rule, number of outcomes. So it's kind of weird, but if you flip a coin 1 time, there's only 2 outcomes, heads or tails. Flip it twice, 3 outcomes, both heads, both tails, or head-tail combination. If I flip a coin 706 times, there's 707 different ways it can come out. So it's statistics, probability, gambling, all built into one on a test that you're gambling your future. So a doublet or a quartet, 1 plus 1 is 2, 3 plus 1 is 4. And then also, how many of you have ever seen the binomial expansion rule, or if you will, Pascal's triangle? Does that sound at all familiar? When you multiply x plus y squared to the third, to the fourth, to the fifth, and so forth. A singlet is just one. A doublet is always in a 1-to-1 ratio, equal height. Triplet is a 1 to 2 to 1. A quartet is a 1 to 3 to 3 to 1. One possible way, 3, 3, and 1. This is just good old-fashioned statistics. So is it okay if, again, bring in something from some other place to see if this works? Event 1, let's just call it P, and event 2, let's call it Q, will distribute in the following way. How many of you have ever seen this where it's x squared plus 2xy equals y squared? How many have seen it this way, P and Q, for whatever reason? Does that look at all familiar? Hardy-Weinberg, binomial expansion in algebra, gambling. I have no, please don't ask me how you spell it, because one, I can't spell LA Unified School District, and two, you'll notice my glaring bio weakness. So I do believe you got the first. There you go. That's how you spell it. You nailed it. So at any rate, let's figure out what happens. If you have equal probability, 1/2 and 1/2, 1/2 squared is 1/4, 1/2, 1/4. Is that exactly what we get with a triplet, a 1 to 2 to 1 ratio? So whether I'm flipping coins, I'm counting cards in Vegas, I'm doing Hardy-Weinberg, which I'm not sure how to spell it, or I'm doing NMR, or we come up with the same thing over and over and over. That same math distribution ends up wreaking its head in lots of different things. A lot going on. So 3 things: the shift value, the area under the curve, and then does a neighbor rule make sense from the ways your neighbor can distribute? So is that seeming a little more clear? Perfect. So back to this one. For this group right here, it is 3 H's. It is close to O, and it has 0 neighbors. 0 plus 1 would be a singlet. This one over here has 9 H's. It's farther from O, and it has 0 neighbors, so it would be a singlet. So I can start breaking it down into those 3 categories. What is the shift value going to be based on what functional group is it near? How many H's is it going to be? Area under the curve. And then what shape is it going to be? It's H neighbors. Is this information overload? Are you looking at 3 different things and never the same thing twice? I'm so glad you heard the F in that, because I didn't think I pronounced it. Sorry, totally unrelated to that. But the shift value is known as the ppm on the graph. So when I'm talking about this, where does it shift to? Naturally, they occur at 0. Tetramethylsilane is our sample, and everything is relative to how much is it shifted from 0. So NMR people, for whatever reason, come up with their own language, but if you're going this way, you're moving downfield. It said you were deshielded, meaning you have a magnetic field near you that you have to overcome. And there's a phrase that I remember: if you want to get up, get down. So how many heard it? It's an awesome late 70s, early 80s dance song. If you want to get up, get down. Meaning if you want to get up in numbers, you get downfield. Or if you want to get down in numbers, you get upfield. So I think the band was actually singing about NMR at the time. But if you want to get up, get down. Get up in numbers by going downfield, or get upfield by going down in numbers. It's just the numbers and the field are listed differently. And so it's their language of what they say. So I'm such a simpleton when I think about these things. My perspective is like way too elementary, but it works. How close are you to the pipe? How close are you to the magnet in the haystack when looking for those needles? Same sort of thing. Up in numbers is getting closer to a lot of magnetism. Exactly. need more parts per million of the magnet to find it. Exactly. Take 5 seconds, 10 seconds to say that to yourself again and organize that in your head, because that is exactly what we're talking about. And then I'm just going to tell you memorize a bunch of numbers. But that's where those numbers come from. It can be a little misleading because benzenes have a really high number, because the benzene ring, the electrons can actually start moving around the ring and create a magnetic field. Kind of a weird phenomenon that kicks in. But if you're near electrons or ring systems that have conjugation, those are going to make you shift downfield. Okay. X-axis. The y-axis is intensity. So that's totally open to like the one you're running, but the y-axis numbers are the ones we're memorizing for this. Oh, 1700, that's something different. That's IR, that measures carbonyl for a bond. So that's a completely different type of spectroscopy. So NMR deals with magnetic, and for magnetic, IR deals with the light you put in, the energy you put in, and what it absorbs. So IR is simply, it's all or nothing. You put in a certain amount of light, and it only absorbs to have the bond. So if it absorbs 1700, has a carbonyl. Doesn't absorb 1700, doesn't have a carbonyl. So fortunately, IR is all or nothing. And actually, let me backpedal on a lot of stuff. How many are in the category of you never had this in school? How many did not have that as one of the things that popped up? And it gets lost in the translation because what happens, the lab course will teach NMR and IR at some schools. The lecture course will teach it, but every now and then you have a school that crosses it up and neither of them teach it. You're not the first one. I can tell you over the years, had plenty of people who have a degree where clearly they took a year of OCHEM to get it, who haven't seen NMR, haven't seen IR, haven't seen UV. I don't know how it falls through the cracks at some places, but it just does. First semester teacher expects second semester teacher to teach it. Second semester assumes you already learned first semester, whatever happens. But there are certain things that for whatever reason get lost in the cracks. So does this help at least as a starting point for this one? Okay, and you are being asked to learn something that takes multiple weeks to learn in half an hour, not gonna happen. Has it come with exposure? So cling to what you can, ask the questions when you need, and repeatedly ask this in office hours. Bring this back up over the next course of the week or so, 2 weeks, whatever it is, till you start getting it to the point you feel somewhat comfortable. Okay, this question is a just screwing with you one. Oh, thank you so much. Have a great evening yourself. I'm sorry if I've lost track of time, like where I'm coming up on things, but hopefully it's still a little time left. Okay, mass spec is another one of those things that is actually not on the MCAT, except the machine in physics. They want you to know how a mass spec machine works with electric fields and magnetic fields interacting. But what does the mass spectroscopy tell me? The one and only thing I need to know that it tells me? M to Z, mass charge ratio. So is this one of those things in physics that's pretty common? Mass charge ratio. And in physics, I called it M to Q. Z in this case is nuclear charge, which is fine. I mean, or net charge on it. But Z or Q, same story. So if you have a hydrocarbon, so let's go back to this compound. We had CH3, carbonyl, C, and then I'll write it structurally. Is that going to be an odd number or even number mass? What's your intuition tell you? So let's see, 5 carbons, 6 carbons, H12O1. Even number, 12 times 1, even number, even number. So the mass is going to be an even number. Okay. What is interesting is what the heck would cause it to be slightly heavier? So where this question is getting at, the only difference is whether you get another peak, one higher with a tiny small peak, or one higher that's actually kind of significant. Yeah, so excellent question. How do we know this is the compound? How to deduce it from the passage? So they do at least tell me it's an organic molecule and tell me the atoms it's made of. So I did know it had to be even. So the even number is fair game because it's an organic compound that contains carbon, oxygen, and hydrogen. All carbon, hydrogen, oxygen molecules will have an even number for molecular mass. But what it gets at every now and then is it possible instead of being 1H, it's 2H, a deuterium instead of a hydrogen, or a carbon 13 instead of a carbon 12, or an oxygen 17 instead of an oxygen 16. So if you look at the periodic table, you'll notice carbon is 12.011, H is 1.008, oxygen is 15.999. What does that mean? Why are these numbers what they are? Actually, I got to look and see if we went into that much detail. Unfortunately, yeah, I don't have enough sig figs. Isotopes. A very large quantity or minimal quantity of isotopes? Minimal, meaning I'm going to get 116, but every now and then there might be a hydrogen a little heavier here, or carbon a little heavier, or oxygen a little heavier, or hydrogen heavier. Minimal times all these possibilities of where it can happen add up to a notable amount. So it's basically has to be an even number with a small isotopic influence. That is the one and only mass spec question one to toss in the whole book. And I go back and forth whether to keep it in there or not, because mass spec, although formally not tested in OChem, it is still something that shows up. And you do need to know that they'll tell you we get the mass from mass spectroscopy. So basically, whatever number they give you, you need to know that's the weight of the compound. That's the only real thing to take home from this. So hopefully it seems okay. You're welcome. And then a couple physics questions. And again, I apologize. I just wanted to go slow and methodical always in office hours. So hopefully it's not dragging. This one, I mean, gotta admit, I love this question. But using data in table 1, the relative drag force versus buoyancy can be determined by comparing. First off, what is buoyancy? Shoot, I just realized I need to grab my book because I need to know something about the densities. Just a second. It's very similar to normal force. Let's figure out the difference. The normal force is when you're standing on a liquid or standing on a solid. If you stand on a solid, push on a solid, the solid push back. Newton's third law, equal and opposite. That's a normal force. What happens if you try to stand on a liquid and you don't have some mystical, magical power? You start to sink into it. But you sink all the way, or eventually, if you start sinking in, does the liquid you're pushing out of the way start to say, hey, wait a minute, I don't get pushed out of the way. You can't push me around too much. And eventually you push around so much that it starts to push it back up. That's a buoyant force. So are they seemingly similar, the normal force with a solid and the buoyant force with the liquid? Equal and opposite, okay? So when an object is falling through a liquid, is there a buoyant force holding it up? Okay, so weird sort of question. Let's say you catch a fish and you're reeling it in. Would it feel heavier when you're reeling it in underwater or once it leaves the water? Where's it going to feel heavier? Okay, that one didn't help. Out of the water, okay. Let me ask a different one. if you have a boot filled with water in a swimming pool, so sorry, can you lift it up pretty easily underwater? If you have a bucket of water, put a bucket in the pool, can you, as long as you're in the pool underwater, do you lift up the bucket pretty easily? But if you try to start lifting it out of the pool, does it get heavier and heavier and heavier as you remove it more and more from the pool? Yes. Why? What has changed? The buoyant force. Exactly. The buoyant force is holding that bucket of stuff up underwater, making it seem lighter. But as soon as you're out of the air, there's no water pushing up on it anymore. There's no equal and opposite force. Okay, so we're good on this. So buoyancy is we define it as the weight of displaced fluid. When I put that bucket into the pool, the water that used to be there is pissed off and wants to go back. So it's going to push its way back in using all of its weight, the weight of displaced water. Okay, what is a drag force? What does that mean? Air resistance, oil resistance. In fact, is that a major concept in electrophoresis? Why do we use gel electrophoresis instead of vacuum electrophoresis? Drag. Because if we used air, if we used vacuum, would it go too fast? Sure. So the drag force, drag force is going to depend on how much it interacts with the medium and how thick the medium is. Okay, so in this case, then we want to figure out the effects of drag and buoyancy. Okay, so the key thing in this passage, do they tell me anything about the relative densities and size of A, B, and C? And I'm going to count on your help because, again, I'm that old person who should have bought glasses years ago, but I'm refusing. I'm trying to make it like through all of life without ever getting glasses. I don't know if it's going to work out. So within the passage, anybody who's playing along, do they tell me anything about these? Okay. It tells me volume of A and volume of B for the spheres are less than C. That's like the start of the third paragraph. Okay, so that becomes pretty important. Okay, or second paragraph, excuse me, that's in there. Okay, does it tell me anything about the density? It tells me mass of A is greater than mass of B, which is equal to mass C. Based on that, which is the most dense? Which is the heaviest with the smallest volume? Let me be better with my symbols because those are rows and I don't want to mistake it for pressure. Hopefully that seems okay. A is most dense, perfect. And then they also tell me something about viscosity of the liquids in the third paragraph. So they tell me the density of ether, density of X, and they're all less than the density of the oil. And then they tell me the viscosity. Actually, I'm going to go with the real symbol. I apologize for that, but they tell me the viscosity of ether is less than the viscosity of X. which is equal to viscosity of the oil. Ooh, a lot of information to keep track of. So these are for my solids. This is for the liquid. Okay, so I have all this information. That said, tell me, what is the equation for buoyant force? Ooh, excellent question. Did I just go through a ton of work reading the passage when you told me I could have gotten it from this? So let me see if this is right. See if I understand what you're saying, Brooke. Are you telling me the more dense the object, it should sink faster or slower? Okay, denser things should sink faster. And is that true? Is A taking less time than B? Is A taking less time than B and C? Perfect. Okay, help me out on this one. Which one should it take longer to fall through? Something highly viscous or not as viscous? More viscous should take more time, which means ether should take the shortest time. Ether is taking less time for B. Ether is taking less time for B is for ether is taking less time than liquid X, taking less time than oil. Perfect. So you mean to tell me, do the numbers in the table match with what you're seeing here then? Sure. So now you get to help me out. I want to study buoyancy as opposed to drag force. So what is the equation for the buoyant force? It's going to help me a bunch if I actually knew that. Rho GH, perfect. And sure, it's rho GH, really, really close. It looks so similar to a force equation. So buoyant force, again, is the force of displaced medium, the weight of what you moved out of the way. So help me out with what the units are of everything. So what is density equal to? Density is mass per volume. So if I take mass per volume times volume, I'm left with just mass. Mass times G, mg, is mg a weight, a force? But I want to be careful. It's density of the medium and volume displaced. So if it's floating, it's a volume of how much water has been pushed out of the way. If it's sunken, it's equal to the volume of the object. Okay, so if I want to study and isn't it one of those things when you see it, it's like, damn, it makes more sense all of a sudden? Those are the little things. And those little snippets here and there are what learning, that's the cool thing about learning. And I think we have those for the rest of our life, and when we have these things, they're so cool. Mine lately have all had to do with language. And I swear, this is really lame, but all the spells they were saying in Harry Potter, which are basically just distorted Latin, suddenly were making sense based on Spanish. It was like, no way, that is so cool. And it was just so, like, I remember having that revelation watching a fictional story, but it's so, those moments are so cool, cling to them, enjoy them. So anyway, for that, yeah, so mass per volume times volume, mass G, I'm set on that one. So will the descent times of A in oil and B in oil tell me anything? So A in oil and B in oil. So when I look at this, A and B have the same volume, moving through the same gravitational field, through the same medium, which means, do they have the same or different buoyant forces? Exact same buoyant force, meaning I can learn nothing of the buoyant force from this one. They have the same F buoyant. Didn't help me at all. Okay, what about in ether? Looking at A and B in ether, is that the same story? A and B ether, is that, again, same buoyant force? So that one's also out for the same reason. Okay, so C and D are at least looking better because I'm thinking about more stuff. So the ratio of the descent times of sphere A in oil to B in ether with the ratio of the descent times of B in oil and C in ether. Oh shit, that's tough. I'm going to lose track of things there. Ratio of descent time of B in oil to B in solvent X, and the ratio of the descent time of sphere B in solvent X to B in ether. Ah, this one Does this one have too many things going on? So let's figure out what the difference is. So I'm going to start with D because there's at least a little consistency. So if I'm comparing B in oil to B in solvent X, what is the difference between X and oil? X and oil have the same viscosity, but they have a different density. Okay, so is the first part of this density, therefore, is that different buoyant forces? They have the same viscosity, but different buoyant forces. Comparing it to so solvent X and ether. Solvent X and ether have X have the same buoyant force, but different viscosity. So this one is does that make sense? This is a really weird question, but totally doable. And I apologize. I want to go through everything to analyze it. To answer this question, we're focused on this. This one, same buoyant force, so nothing's changed. Here, you have a change in the buoyant force in one experiment and a change in the viscosity in the other experiment where you have consistently the same sphere. Here, you have a different sphere in a different medium and a different sphere in a different medium. So you have a different buoyant force and a different viscosity and a different buoyant force and different viscosity, meaning you're not, here you're comparing just buoyant force and just viscosity. And so you can make a comparison, which factor was bigger. So if it ended up that these two fell about the same time and these two fell drastically different times, viscosity was more important. If these fell at drastically different times and these were roughly the same, then buoyant force would be more important. Whereas here, there's too many variables. So does that make sense that this one, not enough variables, this one, too many variables, this just right? Keeping the solid the same, but varying the medium. Really, really tough question, but a really good passage. That's actually one of those passages that's right up the alley of making you think and process things. Okay, last question. Really tough question again, and I hope this visual will help. And if you haven't done this, I'll try to go like, just remind me to slow down as we go. But for the following open-ended YouTube, so open-ended means they're both open atmosphere, meaning atmosphere plus column equals atmosphere plus column. What is special about that line right there that I've drawn in? What is that dashed line telling me? Is the fluid moving or is it stationary? Stationary. That means the pressure that the blue is pushing down this way must equal the pressure of the green pushing this way. So that amount of blue is offsetting that amount of green. Okay, we'll worry about it in a second. For the first part, solution Z is denser or less dense than water. So from this picture, you can tell me whether solution Z is more dense or less dense than water. Less dense. Why? It's displaced by the water. It's floating on top. The less dense on top, so because it floats on top of the water, so it must be less dense. So can I get rid of A based on that? I don't care what the rest of it says. Get rid of that one. Now I need to consider the following. I'm going to change my picture and say, I don't care about this bottom part. I only care at that equal line right there. So I'm basically going to change the picture into this. So this side, atmospheric pressure plus rho GH of this one. I'm calling it 1 when I should call it Z because I'm on side 1. So I apologize for the subscripts. And this side, water, I'm calling 2 just because 1 and 2 is easier to put in. But atmosphere plus column equals atmosphere plus column. Atmospheres cancel. So I'm left with this. Okay. I'm only going to consider that column and this column. So I want to get rid of the bottom of that picture. So the bottom was just stuff pushing back the other way. So this column here was pushing that way. This column here was pushing that way. Because it's not moving, they're equal. So a column with height a plus b of this solution Z is doing the same thing as a column of height b of water pushing the other way. So first and foremost, tell me, do you think water's more dense, or do you think or Z, whatever it is, the oil that floats on top of water is more dense? Water's more dense. So I know the numerator has to be then a small number over a big number, small over big, small over big, small over big. Didn't help me. All worked out. But that would have been a nice thing to get rid of. So at the very least, I could have also gotten rid of this one because it has to be a smaller number over a bigger number. I just got to do the math. So rho GH equals rho GH. Can I cancel G's? Those are going to be gone. So rho H equals rho H. So the density of Z times the height of Z equals density of water times height of water. So plugging in, or well, actually, excuse me, cross, going to divide each side by H1, each side by density 2. The relative densities of Z over water equals the relative height of water over this. So it ends up being then, the height here is B. The height of this one is A over B. So the relative density is going to equal then, oh shoot. Sorry about that. It's got to click in. I'm so sorry. I was starting to write and I thumbed it. Okay, so plugging in row 1, which is Z, is going to equal, oh, sorry, I should have the B. It's going to equal B over A plus B times density 2, which is density of water, which means the best answer is D is in. Damn, that's a tough question. Okay, is there a faster, easier, better way? Kind of, intuition. Is the amount of Z about equal to A? I mean, to water. Would you agree it's just a tiny bit more? So the number you're going to multiply by, do you agree, has to be relatively close to 1? It cannot be A, a small number, over B, a big number. That's just unrealistic. And A, a small number over A plus B, is even smaller. This number is close to 1. And these are close to equal height. Therefore, they are close to equal density. Does that make sense intuitively? Is that a quick and easy way to double check? Fraction's too small, fraction's way too small, fraction works. Okay, you could answer, if you were pressed for time, you could totally do it that way. I like the math solution first and then intuition second to double check, but hopefully that seems okay. That falls in place nicely. Oh, so water is more dense? Which one is floating on top of which one? So before I drew it in, and by the way, water is green. I don't know if that's messing with it, but the original picture had, it was a tube set up like this. So is the solution floating on top of the water or going below the water? So right here in this interaction, you agree the Z is on top. So which one goes on top? The more dense or less dense one? Which one floats on top? Less dense floats on top. So because the Z is floating on top of the water, must be less dense. It was more dense, it would sink to the bottom and water would float on top. So does that seem okay or seem reasonable? Perfect. Yeah, so getting rid of A was the only one we could get rid of pretty quickly. But hopefully this one seems okay. That D is the right answer going through all our math, but it's also the right answer simply because too small a fraction, about run. So best fraction of all. Okay, I think that covers it because the person who submitted the other question isn't here, so I'll save that till tomorrow. So hopefully all seems well, and I've used up the 2 hours anyway. You are so welcome. I hope all these things help and the big picture is falling into place. And again, whatever, the lectures are set for physics for this upcoming week and next week. So I'm doing fluids Tuesday. I'm doing circuits on Friday. I'm doing sound next Tuesday, a week from this Tuesday, and then mirrors and lenses a week from this upcoming Friday. And then after that, carbonyls, carbohydrates, and spec, I think are going to be the 3 OChem ones. And then based on feedback, thermokinetics seem to be getting that. So yeah, you guys just feed into Tiffany. And I mean, I want to like make sure you're getting something a little more quality and honestly more MCAT prep-ish, like how to answer questions, not necessarily just a vocab list that you could memorize on your own, probably more effectively. But again, try and do it within the context. Yeah, wait. Once Tiffany sends me something, I'm probably going to wait until after like Coy's Wednesday lecture to see where they're feeling. So I'm I want to wait 100 or just till she sent it. So she sent the preliminary feedback, and I hope that your guys' votes are the ones that count, that people actually show. But hopefully that all works out. So anyway, so again, thank you for just your energy as always. And I will either see you tomorrow for office hours or Tuesday. Yeah, ask a question, but only if it's stupid and only if it's really quick. So you can't ask a smart question, promise, and you won't ask it a long time. It'll be really stupid and really quick. I'm sorry to be such a smart ass. It's wrong. I'm trying a different approach, but you can ask any and all questions because the stupid question is one you don't ask.
Okay, sorry. I just thought it might be easier to say it. So when we're drawing an anode cathode to 2 plates, like in the Millikan experiment, and then
Yeah.
I understand like from when you draw the actual anode and cathode, like fat cat is the cathode side anode, but then when you draw the charge to the plates, what's the charge on the plate?
Excellent question. So if you actually have to figure out the plate charge, which in some instances you may have to know such a thing, then which way do electrons flow?
Electrons flow to the anode.
I don't know. Electrons flow alphabetically?
Oh, yeah.
Yes. So electrons flow anode to cathode. So this cathode actually is a negative surface, and this is a capacitor with stored charge on it. However, we define this anode as negative because it is repelling electrons away. So the battery, the voltage source, the chemical reaction, whatever you want to call it, has a negative anode. On the other side, electrons again are flowing anode to cathode. So the anode starts losing electrons and will build up a surface charge that is positive. And the cathode is said to be positive because it is attracting the electrons. So if you ask me what charge it is, this is where the whole confusion kicks in. It kicks in because as a biochemist, we care about gel electrophoresis. So we only care about what happens in this region in the capacitor. So a biochemist will tell you the cathode is a negative surface, the anode is a positive surface, anions migrate to the anode, cations migrate to the cathode in gel electrophoresis. The physicist will say, hey, whoa, time out, biochemist. We don't care about this. We care about what makes the whole thing go. Without a battery, you don't get plate charges. So the battery is what we care about. The cathode is positive, anode is negative, is why we say current flows from the cathode to the anode pushing positive here, pulling positive there. So when you say which charge is which, is there a discrepancy between biochemists looking at electrophoresis and a capacitor and physicists? So, and this is why it's such a frustrating topic, because you learn it differently in two different sciences. And so this isn't a stupid question. This is actually a brilliant question that everybody gets tripped on some point because it's defined differently. You learn it in one class one way and then another class differently. And of course it gets confusing because nobody takes the time to explain what their perspective is. So does a fence keep people in or out?
Both.
Perfect. All in perspective. So if I told you you lived in an elitist community, a gated community with guards protecting the perimeter, that's so sacred that you have to be voted in by 12 people to be allowed to live there. It's that exclusive. And they feed you, there's this meal, there's a gym. They actually help you with your outfit. You get to wear these wonderful clothes that are usually orange with a stencil number on them. That fence keeps everybody out so they can't join your exclusive neighborhood. Although, where have I just described?
Prison.
Perfect. So it's a gated community, and you did have to get selected to be able to join, but it's all in perspective. Did that fence keep you in or out? All how you look at it. Is it anode negative or positive? All how you look at it. Not to say you're going to prison.
Okay. No. This is why I was confused on that question. And then
this is why everybody gets confused. But
and then
now
in one of the questions, then they flipped the charges and wanted to know what happened. And then I got really confused.
Yep. And that's why
I only deduced it because they said that the oil gets a negative charge when it comes out of the can or whatever. And so the only way it could stay in the middle is if the bottom was negative.
Perfect. Yep. So electron flows anode to cathode, goes from oxidation to reduction. Anions migrate to the anode. Cations migrate to the cathode. That is true for everything, everywhere, all the time, which is why I recommend doing this and avoid all the confusion of who's asking to just give you an answer. Number two, you now owe the universe an answer. So, which I'm sure you'll pay up. You'll answer and help somebody down the road.
For sure.
Yeah. When should you start double AMC material? Totally depends on when you're taking the MCAT, but count back 6 to 7 weeks. So if you're taking it in early January, then yeah, you want to start probably 2nd to 3rd week of November. If you're taking it the 3rd week of January, then probably December 1st-ish. But double AMC become absolutely essential. And I'm going to start having like dedicated office hours. You're going to see me be unbelievably anal about it though. And that is, you don't get to come to double AMC office hours unless you don't even get to ask a question until you can confirm you've done that. I don't want to spoil anything because they are by far the best materials out there. And if you see them in advance, it takes away the credibility of whatever score, whatever performance you have on them. Oh yeah, so double AMC, you want to start when you've done enough review to be able to start them, but not wait so long that you don't get as much out of them by the time you take your test. So if your test date is early January, then you probably want to start mid-November. If your test is late January, then probably around December 1st. And that it's just a ballpark. I mean, nothing sacred about December 1st other than to toss that. But you want to give yourself about 7 weeks. You want to start with section banks and QPACs, and then move to the full-length test after about a week or two of doing their practice. And then time it to do their last 2 exams right before your MCAT. And to the best of my knowledge, it's still 1 sample test and 4 practice tests. Do you know at all, has anybody heard anything? Because what they say changes so often, whether they're going to have another full-length exam coming out. How many have heard they are, and how many have heard it's not happening? And how many don't know? You'll just, whatever they get, Whatever they give you, they give you. Yeah, nothing new. COVID messed up everything because their plans to put out one more test, I know it should have happened by now. It should have happened last November, at the very least this November. I think COVID just sort of put a wrench into their crankshaft. Alrighty. Well, I hope I will see you tomorrow. So office hours after lecture. If not, I will see you Tuesday. And just to confirm, what time are we meeting on Tuesday? West Coast time. Perfect. So exactly. So same Monday, same time. Always this link. Yeah, I have to set it for after lecture. So even if, so basically because there's a, yeah, exactly. Has to be after that. All right, so I'll see you either tomorrow or Tuesday. So have an absolutely time out. Absolutely wonderful night. Thank you so much. Thank you guys. And Brooke, sorry to pick on you so much today. Just I don't know why. This looked like I had a giant target on you today.
I asked a lot of questions, so it's really fine.
No, you didn't. You asked a lot of good questions. Dropped the word a lot in good questions. But I think partly because the apologizing beforehand, which I totally get, honestly, from in my heart, I always do the same way. Feel the same way. I just want to apologize when I ask. I hope you don't feel the need to apologize. I mean, this is your future, and you should ask. And
I
your
just
questions
felt
are
bad for
always good.
dominating.
Oh, you know what? If I've learned anything teaching over the years, it's that if somebody doesn't step up to put stuff out there, it's less of a class. It's just, you need questions and you need just, I know, it needs to be a dialogue. People learn dialogue better than monologue.
Totally.
And so, yeah, the more you toss out there, the better. And even the feedback, I'm telling you, the feedback of your group is so awesome. It's just really motivational. So do not ever apologize. I would be bummed if you didn't ask questions, because it'd be just me talking the whole time, and that doesn't do anybody good. So anyway, oh, it would suck. Yep. And I got to admit, it was painful listening to today's lecture, and just sat there and unfortunately, yeah, it's hard from all ends, but especially hard teacher end. But yeah, just listening to the way things were today, and I had high hopes. This was Josh's big, what he thought was the big score, because she had a lot of teaching experience on paper, but it just based on the attrition, it just was tough. Yeah, I don't know. Maybe. I got the impression the other way. I got the impression it was reading a script. Yeah.